Hello friends, I welcome you in lecture number 10 on partial ordering. In this lecture we are going to discuss one question on hash diagram which was asked in GTU Summer 2021 exam. First we understand what is this question. Draw the hash diagram of the set having 4 elements 1, 3, 9 and 18 under partial order relation divides and indicate whether the set is a chain or not. We have discussed about this chain. Chain means it is another name for totally ordered set. Totally ordered set is special type of partially ordered set in which any two elements are comparable. If you recall the definition of totally ordered set, then we have seen that suppose P is a partially ordered set under some partial order relation denoted by less than or equal to, then if for any two elements xy belongs to P, if x is related to y or y is related to x, then this partially ordered set is called totally ordered set or a chain. So in a chain or totally ordered set, if we take any two elements from the given poset, then they are related to each other. Either x is related to y or y is related to x. In this question, first we have to draw the hash diagram of partially ordered set which is having divides relation, and then from the hash diagram we have to decide whether the set is a chain or totally ordered set or not. So first we try to draw the hash diagram of this set having 4 elements. So here relation is divides relation, and it is clear that 1 divides 3 and 1 is not equal to 3. Therefore we can say that 1 is less than 3. We know that less than or equal to is the notation for partial order relation, and less than is the relation which is associated with every partial order relation, but here we are not considering equality. So that is meaning of this. And we know that if 1 is less than 3, then circle for 1 is drawn below the circle for 3, and here 3 is a cover of 1 also, and we don't have any element say z such that 1 divides z and z divides 3. There is no z in the given set such that this happens. So 1 is covered by 3 or 3 covers 1. Therefore we will join the circles for 1 and 3 by line segments. Similarly, if we consider these two elements 3 and 9, then 3 is less than 9, that is 3 divides 9, and 3 is not equal to 9. This is meaning of this notation. 3 is strictly less than 9, and here also we can see that 9 is a cover of 3. There is no element in between 3 and 9 in the given set such that 3 divides z and z divides 9. Therefore 9 is a cover of 3. 3 is a cover of 1. And similarly 9 divides 18. 9 is not equal to 18, and there is no element in between 9 and 18 also such that this happens. Therefore 18 is a cover of 9. And here we first try to draw the hash diagram. So each element is having a cover. If I consider 1 and 3, then 1 divides 3 and this 3 is a cover of 1. Similarly 9 is a cover of 3 and 18 is also a cover of 3. So whenever one element is cover of another element, we join them by a line. Because 3 covers 1, we consider line between 3 and 1. Similarly 9 covers 3, so we join them by line segment. 18 covers 9, therefore we consider line segment between 18 and 9. And this is the hash diagram of given set under divides relation. This is hash diagram of the partially ordered set which is having 4 elements, and the relation is divides relation. Now from this we have to decide whether this relation is a totally ordered set or not. So whenever our hash diagram of a partially ordered set is looking like this, you can see this hash diagram looks like a chain. There is a chain like structure. If you imagine the structure of chain in real life, then you can see this diagram looks like a chain. So whenever hash diagram of a partially ordered set is a chain or is looking like a chain, then we can say that given partially ordered set is a totally ordered set. And here we can see by the definition also, if we take any two elements from this set, then they are related. We can see that if I take 1 and 3, then 1 divides 3, similarly 1 divides 9, 1 divides 18. Then if I check for 3, then 3 divides 9, 3 divides 18, similarly 9 divides 18. So this happens for any two elements. If we take any two elements, say x and y in a given set, then either x divides y or y divides x. Therefore by definition also we can say that this set is a totally ordered set. And from the hash diagram we have to remember that if hash diagram of a given partially ordered set looks like a chain, then that partially ordered set is a totally ordered set or chain under given partial order relation. Here hash diagram of this set 1, 3, 9, 8 under divides relation looks like a chain, therefore it is a chain. So here we can write that given set is a totally ordered set is a totally ordered set or a chain under given partial order relation or under divides relation. Under given partial order relation, and that relation is nothing but divides relation. So in this way we can easily answer this type of questions. Here we have to draw the hash diagram of this partial ordered set, and we have to answer whether this partial ordered set becomes a chain or not. So because hash diagram looks like a chain, we can easily say that given partially ordered set is a chain. Now if you recall, we have seen inclusion relation also. Suppose I consider this set, say P equal to set having 4 sets, collection of 4 sets, set having one element, say A, then 2 elements, and say 3 elements. And suppose I consider inclusion relation. Suppose I consider this set with inclusion relation, then we know that this set is a partially ordered set, and we can easily see that this phi empty set is covered by a set having only one element, because phi is a subset of A and there is no set in between these two such that we have phi is subset of Z and Z is subset of A. Therefore this set having singleton element A is a cover of phi. Similarly we have already discussed this type of things in earlier lectures also. Set having AB is also a cover of set having only one element, and a set having 3 elements ABC is a cover of this set having 2 elements under this inclusion relation. So you can see this is the hash diagram of this partially ordered set, and if you compare these two hash diagrams, then they are exactly same. Here we have chain of 4 elements, and here also we have similar hash diagram. The only difference is the elements are different. Here we have elements of the partially ordered set are sets, and in earlier case we are having these positive integers 1, 3, 9 and 18, and here we have divides relation, here we have inclusion relation. So this is very important thing, and why this happens, that we will discuss in upcoming lectures. This type of partially ordered sets are called isomorphic partial order sets. We have discussed the concept of isomorphism in group theory also. So the structure is same, and this type of sets or partially ordered sets are called isomorphic partially ordered set, that we will discuss if that topic is in our course. And here for this partially ordered set also we are getting a chain in the hash diagram. Therefore this is also an example of chain or totally ordered set. So this is all about this session. I hope you like it. If you have any questions or doubts, you can ask in comment section. Thanks for watching.